Alright guys, let's go ahead and look at our trophic cascades. So ecosystems are comprised of different communities of organisms in a physical environment. We study the interactions among those organisms and how they affect organisms' distributions. The structure can be represented by a pyramid here with trophic levels. So the bottom are your producers, then you'd have your primary consumers, secondary consumers, and so on, depending on how many levels there are to your pyramid. So we're going to see what's happening in this trophic pyramid.
Knew the sea urchins were common but very small. With no otters. The most dramatic
So we're now going to look at direct versus indirect effect in our trophic cascades here. So indirect effect, the sea otters not controlling the sea urchin population can mean they can eat that all the kelp will be gone. So if we're looking at a kelp example here, so we want to track the ecosystems and see what happens to the different communities of otter, sea urchin, and kelp. So here the solid line represents a direct effect. The amount of sea otters affects the population of the sea urchins. The minus sign means it's a negative effect since they are consumers of the sea urchin. The sea urchin eats the kelp. That's another negative effect. That directly affects the amount of kelp. So throughout the 1800s, like they were talking, the sea otters were hunted to near extinction along the Pacific coast of North America. So how did that impact these ecosystems? If you take away your secondary consumer, what's going to happen to your primary's population? As otters disappeared, the sea urchin population exploded. As that happened led to the disappearance of the kelp. So a consequence of hunting the otters to near extinction indicates that that predator can have a top-down effect on the whole ecosystem. So even though it's only affecting the consumption of the sea urchins, that's also affecting the amount of kelp that's eaten indirectly. So we can connect it with a dashed arrow. The sign is a positive effect because the population of otters are mirrored by the proliferation of the kelp forest. So there are more complex than this, but this is just an example. So it says, what happened to their diet when the otters disappeared? Of the skull. So with otters present, there were more fish, less invertebrates. When the otters are gone, there are less fish, since there's less kelp, and more invertebrates. So that means they had to adapt. The skull had to adapt their diet from fish to invertebrates. So let's see the bald eagle. What happened to their diet when the otters disappeared? So with otters present, 40% birds, 35% fish, 25% mammals. They had to shift their diet to eating more birds and fewer mammals as a result of the change in the habitat. This and the gull, so bald eagles and the gulls, both birds, illustrate how effects from one species loss can be transmitted throughout an entire ecosystem. So I can see that this otter is a keystone species. And then there are different case study options. So we want to look at the Arctic tundra. In addition to controlling the relative amount of primary productivity, trophic cascades can also change the landscape by altering the movement of nutrients in a community. Think of our nutrient cycling. So in this example, the introduction of Arctic foxes had effect beyond the birds that they ate. So we want to know, do the foxes have a positive or negative effect on the seabirds? Let's see. They probably eat the seabirds, so we're going to go negative. So since the foxes prey on the seabirds, if their numbers increase, there would be a decrease in the seabird population. So seabirds to soil nutrients. Let's see. Seabirds' poop or droppings are rich in source of nutrients, and more birds means more nutrients. So the birds have a positive effect on the soil, which in turn, these grasses would have higher nutrients than other tundra plants, so more nutrients means more grasses. So it says, which landscape illustrates the addition of foxes to a system? So we know if the foxes are there, they eat the seabirds, which would mean less nutrients and not as much for grass, since the birds have a positive effect. So if the foxes were there, let's see if the no grass is an option. All right, let's see. When the foxes were introduced to the islands in the archipelago, they preyed on the native seabird population. Normally, they would give nutrient-rich droppings on the island, which would enrich the soil with phosphorus. When the nutrients levels reduced, the vegetation shifted from grasslands to tundra, creating a landscape level effect. So this affected the primary producers in the vegetation here. And then if you guys want to, you can go ahead and look at the different options on here. And it shows different effects that can happen. So we have like Midwestern lakes, what can happen between the different fish. So do bass fish have a positive or negative effect on minnows? Bass fish are going to consume the minnows. Negative effect because they are their prey. Minnows to zooplankton. That is also the minnow is a consumer of the zooplankton. Negative effect. They're the predator. It'll decrease the zooplankton population. If the minnow eats the zooplankton, which the zooplankton eats the phytoplankton, what would happen to the amount of carbon? So phytoplankton, this is where you're going to have photosynthesis happening. Let's see, positive or negative effect. Let's go with negative and see. Let's see. So positive. So since it's going to take in that carbon dioxide, it would have a positive effect on the carbon. But it says which lake illustrates the removal of the bass. So if you take the bass away, it doesn't eat the minnows. Minnows don't eat the zooplankton or the phytoplankton. So let's see if it would be the clearer lake or the dirty lake. Let's see, let's go dirty lake. So changes in the bass alter not only the lake community, but also how the system interacts with the atmosphere. By directly controlling the amount of phytoplankton, the predatory bass fish can alter the balance between the atmospheric CO2 and the amount in the lake.